99%. That is roughly how much of the world's intercontinental internet traffic, every email, every video call, every dollar moved between banks on different continents, and every request sent to an AI model running on a server across an ocean travels through cables lying on the bottom of the sea, not satellites. Satellites carry a rounding error of global data by comparison. Almost 600 of these cables currently crisscross the ocean floor, and in places the actual data-carrying core of one is barely wider than a garden hose, wrapped in steel and rubber for protection, then simply laid across the seabed for thousands of miles. There is no meaningful backup system if enough of them go down at once. Today, on the stack, we trace the wire nobody thinks about until it snaps, and why the company racing hardest to control it now is not a telecom. It is big tech. Before the mechanics, the stakes. Every AI data center that Microsoft, Google, Amazon, and Meta are spending hundreds of billions of dollars to build sites on land, but the model you query, the training data it learned from, and the cloud service your company runs on all depend on moving enormous volumes of data between continents in milliseconds. That data has exactly one practical path across an ocean: these cables. A serious cut to the wrong cluster of cables does not just slow down your video call. It can degrade AI inference speed, disrupt financial trading systems that route through undersea links, and cut off entire countries from cloud services hosted somewhere else. This is not a hypothetical. It has already happened more than once in the last 2 years, and we are about to walk through exactly how. Chapter 1: The Scale. Industry tracker TeleGeography counts roughly 600 active and planned submarine cable systems in service worldwide, running through nearly 1,900 landing stations, the physical buildings where a cable comes ashore and plugs into national networks. Strung together, the world's submarine cables add up to more than 1.5 million kilometers of cable, enough to circle the Earth more than 37 times. Each cable is typically built from a bundle of hair-thin glass fibers at its core, protected by layers of steel wire, copper, and insulation, then buried under the seabed near shore, where ship anchors and fishing trawlers pose the biggest risk, before running exposed across the deep ocean floor for the rest of its length. This entire global network, the actual physical layer the modern internet runs on, is owned, laid, and maintained by a surprisingly small group of players. Chapter 2: The Ownership Shift. For decades, undersea cables were built and owned by consortiums of national telecom carriers, companies like AT&T, Orange, and NTT, who then sold bandwidth to everyone else, including tech companies. That has changed fast. Google now holds an ownership stake in 34 separate cable systems. Meta holds a stake in 20 more. Microsoft and Amazon together have stakes in roughly 10 others. These 4 companies did not just become the biggest customers of the undersea cable industry. They became landlords of the ocean floor, building and co-owning the exact routes their own data centers need most, on their own timeline, at their own capacity, rather than waiting in line behind everyone else's traffic. The company that used to just rent bandwidth from a telecom now increasingly owns the pipe itself. Chapter 3: What that ownership looks like in practice. Meta is currently building a cable called Waterworth, a single system roughly 40,000 kilometers long, enough to wrap most of the way around the planet, connecting the United States, India, Brazil, and South Africa at a reported cost near $10 billion. It follows Meta's 2Africa cable, which reached its core completion in November of 2025 at roughly 45,000 kilometers, looping the entire African continent and standing as the longest cable system ever put into service. Google has taken a parallel approach, funding cables like the billion-dollar Equiano system, connecting Portugal to South Africa, and dozens of others feeding its own data center regions directly. None of this is philanthropy. Industry analysts now estimate roughly $13 billion will pour into new subsea cable projects between 2025 and 2027 alone, nearly double the amount spent in the 3 years before, and the reason cited most often by the companies writing the checks is the same one behind every other infrastructure story this channel covers. Artificial intelligence needs the data to move. and big tech does not want to depend on someone else's wire to move it. Chapter 4, the part that should worry you more than the ownership question. Building a new cable is expensive but routine. Repairing a damaged one is a different problem entirely, and the global fleet of ships specialized enough to do that repair work is small, aging, and was never built for how much the world now depends on this network. Reporting on the industry has repeatedly flagged that only a handful of dedicated cable repair ships operate worldwide at any given time, a fleet expected to handle roughly 200 cable faults every single year across the entire planet's ocean floor. When a cable breaks far from shore, the nearest available repair ship, often stationed thousands of miles away, has to sail to the site, locate the exact break using grapples and sonar, haul the cable up from potentially thousands of meters down, splice it and lower it back, a process that routinely takes weeks. There is no rapid response equivalent for the ocean floor. The system that carries 99% of intercontinental data leans on a repair capacity that was sized for a much smaller, calmer internet. Chapter 5, when this stopped being theoretical. Starting in late 2024, a cluster of cable and pipeline damage incidents hit the Baltic Sea in quick succession, cutting links between Finland, Estonia, Germany, Sweden, and Lithuania. Investigators tracking the region identified at least 8 separate instances of cable damage across multiple incidents through 2025, and in several cases traced the cause to commercial vessels, some with murky ownership tied to Russia or China that appeared to drag their anchors directly across cable routes for unusually long distances. A pattern investigators say is difficult to explain as pure accident. NATO responded by launching a dedicated Baltic Sea patrol mission specifically to monitor and deter this kind of activity. Governments that once discussed undersea cables as a boring utility question started discussing them publicly as a potential front in hybrid warfare. Chapter 6, the other pressure point. The Red Sea carries a disproportionate share of the cable traffic linking Europe to Asia, funneled through one of the narrowest maritime choke points on Earth. Since Houthi forces began attacking commercial shipping in the region in 2023 and 24. Multiple undersea cables running through those same waters have been damaged, including a cluster of cuts in 2024 linked to a sinking cargo ship whose dragging anchor chain sliced through several systems at once, and further cable damage reported again in September of 2025 that disrupted internet connectivity across parts of Asia and the Middle East. Unlike the open Atlantic or Pacific, cable operators cannot simply reroute around the Red Sea without adding thousands of miles and significant cost, which means this single, already dangerous choke point is also a choke point for a meaningful share of the world's data. Chapter 7, the quieter choke point underneath all of this. Laying a new transoceanic cable at the scale big tech now wants requires specialized cable-laying ships and manufacturing capacity that, historically, only a handful of companies on Earth possessed. American firm Subcom, the French-headquartered Alcatel Submarine Networks under Nokia, and Japan's NEC. That short list is no longer uncontested. China's HMN Technologies has expanded aggressively into cable manufacturing and laying over the past several years, backed by state support, and has already won contracts across Asia, the Middle East, and Africa, prompting the same governments worried about Baltic Sea sabotage to also start restricting which company gets to build cables landing on their own shores. It is the same shape of story this channel has told about ASML and lithography, an AI-era essential resource that a surprisingly small number of companies can actually manufacture, which means whoever controls that short list has leverage over everyone who depends on it. So what are the real risks? 3, and they compound each other. Ownership concentration. As big tech builds and co-owns more of the network itself, outages increasingly affect specific companies' infrastructure directly rather than a shared, redundant public system. Geography. A small number of choke points, the Red Sea, the Luzon Strait near Taiwan, the narrow seas around northern Europe, carry a disproportionate share of intercontinental traffic, and cutting the right handful of cables in the right place can degrade service across entire regions at once. And repair capacity, the fleet of ships able to fix a damaged cable, has not scaled anywhere close to how much data and how much AI infrastructure now depends on this network staying intact. None of this means the internet is about to go dark. Redundancy across hundreds of cables is real protection, but the margin for how many things can go wrong at once before that redundancy runs out is thinner than most people assume. Zoom out, and undersea cables are the cleanest reminder this channel has covered that the AI economy is still, underneath everything, a physical economy. Every conversation about GPUs, data centers, and power grids assumes the data those chips are processing can actually move between continents fast enough to matter. And that assumption rests entirely on roughly 600 cables, a repair fleet sized for a smaller internet, and a handful of manufacturers who can build a new one. Big tech has noticed this dependency and started buying its way out of it, which solves their problem while doing very little for the small nations and public networks still renting bandwidth on someone else's line. The chips get the headlines. The wire on the ocean floor is what actually lets any of it reach you. That is the machine economy, one layer at a time. Subscribe now, because tomorrow on Mind Over Money, we ask why subscriptions are engineered to make you forget you're still paying for them.